What if the clean energy of the future wasn't decades away, but already being built today? In a world desperate for sustainable power, one company is racing against time and physics to commercialize the holy grail of energy: fusion. Meet Commonwealth Fusion Systems, a bold MIT spinout backed by over $2 billion in private capital, armed with breakthrough superconducting magnet tech and aiming to deliver fusion energy to the grid by the 2030s. This is not science fiction. This is fusion, reimagined by entrepreneurs. This is the story of how CFS is rewriting the playbook for deep tech commercialization. Fusion has always been a scientific moonshot. Immense potential, but decades of delays. So why is this company different? In this video, we ask, how did CFS turn one of the world's hardest technologies into a credible business? We'll explore what made their innovation strategy stand out, how they earned investor trust in a high-risk market, and how their business model could finally make fusion profitable. First, innovation strategy. CFS isn't just iterating, it's radically innovating. They're building a compact fusion reactor, SPARC, powered by high-temperature superconducting magnets. According to Christensen's theory of disruptive innovation, fusion doesn't start by displacing the grid. It starts in niche, high-value energy markets, then scales. But as Thies told us, it's not the invention. It's who controls the ecosystem. CFS isn't alone. It's plugged into MIT. It's backed by national labs. It recruits from the top of the scientific pyramid. This is a regional innovation cluster in action, just as Feldman and Saxenian envisioned. Talent, capital, and knowledge cycling between academia and enterprise. Second, funding. Fusion used to be government only. CFS flipped the model. Their tech proof, a successful magnet test in 2021, unlocked a staggering $1.8 billion Series B. That's Gompers and Lerner's staged funding model in action. Milestones build credibility. Credibility attracts capital. Capital enables scale. Unlike startups chasing users, CFS sells vision, grounded in physics, backed by prototypes. And third, business model and IP. Their business model? Not licensing, not consulting. They're building reactors, selling energy at scale. Their IP? License from MIT, but protected more by first-mover execution than by legal fences. Bassano would call this the biotech model. Protect what matters, race ahead on the rest. But CFS isn't alone in this race. From Helion Energy in Washington to TAE Technologies in California, a new wave of fusion startups is emerging, each with different technologies, timelines, and visions. This raises a strategic question. Is fusion a winner-takes-all market, or one where multiple players can thrive? According to the resource-based view, CFS's unique assets, superconducting magnet IP, MIT ties, and early mover advantage give it a temporary edge. But fusion also raises big ethical and geopolitical questions. Who controls this future energy source? Will it be open, global, or locked behind patents and private equity? And as fusion gets closer to reality, governments may step in as regulators, customers, or competitors. The innovation-commercialization balance will be tested not just by science, but by policy, society, and trust. That's what makes this case so powerful. It's not just about a company, it's about the future of energy and who gets to shape it. Commonwealth Fusion Systems is not just a company. It's a bet on science, on execution, on the power of aligned ecosystems. Their success teaches us three things. Breakthrough innovation needs strategic ecosystem leverage. Investor trust can be built with technical milestones, not just hype. And business models matter just as much as physics in deep tech. If they succeed, fusion energy could change the world. If they don't, they'll still have changed the rules of how science becomes business. This is deep tech. This is commercialization under extreme uncertainty. This is CFS. And the future? It might just be nuclear, but in the best way possible.